Good afternoon. It's my pleasure to welcome you. Thank you for joining us for this session. This session is building on AWS, the architecture of the Siemens MindSphere platform. My name is Frank Kovach. I'm the Amazon Web Services Partner Development Manager for Siemens, and it's my pleasure to introduce Kathleen DeValk as part of our session this afternoon. For those of you not familiar with Siemens, I just wanted to make sure that your perspective on Siemens really captures the entire capability they provide customers. Siemens is the world leader in industrial automation. They've been in business for more than 170 years. They manufacture products around the globe with more than 300 manufacturing plants and facilities and deliver both physical and digital solutions to their customers. Now, partners work with AWS for a couple of different reasons, one of which is really our depth and breadth of our services that we provide. And AWS probably provides, in the industry today, the largest set of capabilities and features in those capabilities. And what that means to partners like Siemens is their ability to have the right tool for the right job. And it's allowed us to work with Siemens in a lot of different ways. And let me share some of those with you now. So we've been working with Siemens both in two perspectives, one as a partner and as a customer. So we've worked with Siemens in their product portfolio to both lift and shift, to re-engineer, and to go to market together with various products throughout the generation of 2014, 15, all the way till today. At reInvent in 2017, we jointly announced through a keynote with the EVP of MindSphere, Steve Bishada at that time, the release of the newest version of MindSphere that was going to be delivered on AWS in 2018, and it was launched successfully and on time through the partnership. So we're very proud of this relationship with Siemens and look forward to the future that we hold together. One of the other really important points is the qualification and certification of our partners. And Siemens is uniquely one of the only, in fact, the only industrial provider who has both achieved technical qualification and has taken their Teamcenter PLM product and their MindSphere product and gone through industrial certification as well. This ensures for our customers the highest quality and standards of performance and capability. Some of the outcomes of the relationship that are achieved today by customers include things like the benefits of accelerated decision making. And all of this is happening today through the convergence of the IT and the OT environment, the information technology and the operations technology. When these things have been brought together, some really interesting things are happening in manufacturing today. Probably the most significant thing is the transparency that customers are getting today as a benefit from this. The other thing I'll point to, and I want you to keep an eye out for, is relationships around the digital twin. There's some very cool things happening in this area, and the accuracy and simulation of digital twins is just going to get better and better. And MindSphere is a key component to closing the loop in that environment. So it's a very cool capability. I think you're really going to enjoy it. To introduce our next speaker, I'd just like to share a few bullet points with you about her. She's probably the most interesting person I've met in a very, very long time. Kathleen has produced her first SaaS product back in 1999. She's worked with AWS since 2014 with a production product in 2015. She has 2 albums of original music. She is a martial artist. She won in 2008 the Masters Division National Gold Medal at age 35. Her claim to fame is a bout with Ronda Rousey when she was 17 years old. Ronda was 17, and Kathleen said, "She kicked my butt." She's an avid sailor and hopes to circumnavigate the globe someday. It's my pleasure to introduce to you. Please join me in welcoming Kathleen DeValk. Got you, buddy.
Hi, thanks, Frank, and thanks for having me here. Really excited to be here speaking at AWS this week. What I'm going to do is I'm going to tell you a little bit about our journey to build MindSphere on AWS, some of the lessons that we learned along the way, and give you some tips and tricks on how we operate this kind of platform at scale. So MindSphere is operating in production. We have over 475 partners currently that have built 400 applications. This platform is designed to support millions of devices. We handle hundreds of gigabytes of data per second for thousands of customers. Overall volumes of data that we store measure in the hundreds of terabytes. So what is MindSphere? MindSphere starts with connectivity. The most important thing is to connect the devices around the world. We connect devices of any type, anywhere around the world. We provide SDKs and libraries to help you easily connect your devices, but we don't just stop there. We provide a lot of services that allow you to build and allow us to build applications and solutions on top of the platform. These are microservices architecture that deliver over 100 APIs that are available to us to build our applications and for partners also to build applications and solutions. MindSphere has a number of applications that we deliver, that our internal partners deliver, and our external partners deliver. In addition to that, if you need to do something very specific or very custom, we also provide an integration with Mendix, which is our rapid application development environment that allows you to quickly and easily deliver and develop new applications on top of the MindSphere APIs in a low-code environment. This combination capabilities allow you to make use of your data and really put your data to work. Part of the MindSphere strategy is around ecosystem. So it's not just delivering our applications, but it is enabling an ecosystem that allows partners to build additional functionalities. As prosumers, partners, build new content, the new content attracts new customers. Customers attract new partners, and the ecosystem grows upon itself. And we learn from our partners as well as our customers about new use cases, about new requirements, and about new things that they want to do with the platform. And this helps us to constantly evolve and enhance our platform with new capabilities that actually solve real-world business problems for our customers. And this is just a view of our current ecosystem, some samples of some of our customers and some of our partners. And with our integration with Mendix, we have a quite robust application development community around MindSphere. So when you're building this kind of platform, you can get distracted by many things. There's a lot of things that you could build and do, but it's important to understand where is your value add and where are your differentiators, and kind of stay focused, because it's a big world, there's a lot of potential, but if you don't stay focused on your value proposition, you can kind of get lost and waste time on things that maybe aren't really valuable to you. So an example is in MindSphere, we provide these APIs and this capability that work on top of a common data model with a common security model. So any application that's built on top of the platform can make use of this common data model and this common security model. So all applications within the ecosystem work the same on top of the customer's data. And how we do this is to build a cloud-native, cloud-optimized architecture. Part of our strategy around this is we don't want to build anything that we don't have to build. If there is an existing capability that works for us, why reinvent that wheel? Why spend time and effort there? And this allows us to stay focused and innovate more rapidly and deliver new features and value add quicker. In addition to that, we want to ride the innovation curve of AWS. By partnering with AWS, we can take advantage of new technologies that help us scale, about new innovations that help us build and deliver new features that are more interesting. And we focus more on building software that helps our customers solve their problem rather than the undifferentiated heavy lifting. We leave that to Amazon and AWS to worry about. So an example of that is in our use of managed services. You could, for example, use Kafka, which is a great open source technology. It's highly scalable, performs very well. But when you operate it in production, there's quite a bit of work that you have to do. You have to manage the instances and the virtual machines it's running on. You have to monitor and scale it. You have to manage the backup and recovery of all the data that it is handling. Or you can use Kinesis. And with Kinesis, it's fully managed. And it provides automated backup to 3 different AZs. And it's very easy to handle the scaling up and down by splitting and merging shards when necessary. So we don't worry about those things because those things are not our core competency. We take advantage of managed services so we can focus on the real value add that we can deliver with the MindSphere platform. This is a representation of what the MindSphere architecture looks like. And we deliver our content through CloudFront. We use Route 53 to route things. We use ALBs. All of our services are delivered on top of various Amazon compute. For example, containerized services running on ECS. But we also heavily leverage serverless architectures. And we also leverage Lambda and other serverless technologies. It allows us to focus, again, on our value proposition. We use a lot of Amazon services to help us monitor our systems so that we know everything that's happening. We use CloudWatch for monitoring our services. We use CloudTrail to understand how things are interacting with the AWS infrastructure. And this gives us good visibility into everything that's happening within our platform so that we can deliver a high level of SLA to our customers. In 2018, when we went live, this is a representation of the services that we are using. Now we're using many, many more services. And we continue to watch what's coming from AWS. We continue to keep pace with the innovations coming from AWS so that we can leverage the capabilities that make sense to help us build our platform. One of the reasons that we build on AWS natively is that we want to provide the best of both worlds to our developers and the partners within our ecosystem and to our end customers. This allows people building on MindSphere to take advantage of everything MindSphere has to offer, but also everything that AWS has to offer. For example, you can use MindSphere's very robust connectivity suite, which is highly integrated with digital factories. And you can also use Amazon's connectivity suite. You can feed all of this data up into MindSphere. And MindSphere, again, it contextualizes this data, provides you a common representation of the data model and a common security model so that our applications and our analytics can unlock the insights across your entire data set. In addition to that, if you want to bring your own tools, we have an open platform that allows you to bring your own tools. So we unlock our data lake to things like SageMaker or EMR if you want to run batch processing or you want to run machine learning jobs. So you can have the best of both worlds in building your applications on MindSphere. So let me tell you a little bit about how we design the systems and how we deliver these systems. One of the design patterns that we start with is a containerized design pattern. So when we deliver software through containers, we don't want to do quite a bit of management of the EC2 instances, and we don't want to worry so much about the scalability. We want to leverage the AWS capabilities to help us with that. And by deploying our containers onto ECS, we get the advantage that ECS will automatically allow your containers and your cluster to be spread across multiple AZs. So you can have automated failover in multiple AZs. This allows us to achieve our level of SLAs for our customers. In addition to that, we make sure that we leverage AWS RDS. We don't manage our own databases. I think managing a database, who wants to manage a database? That's not what we do. We build software. So let Amazon run your database for you. RDS provides you all of those capabilities, and you don't have to write scripts to back up and recover your database. You just configure it. You configure AWS RDS to be multi-AZ, and so you have automatic failover. When we first went live, we did a test just to see what would happen, and we wanted to know how fast the failover was. So we had a little game day, and we said, we're gonna simulate some scenarios where something goes wrong. And the development team said, you mean we're going to break stuff and see what happens? And I said, yes, that's exactly what we're gonna do. And let's have some fun doing it. And when we did it, we found that within seconds, the RDS automatically fails over from the primary to the secondary. And within less than a minute, the write replica fails over automatically, and you don't have to do anything. And so we leverage those capabilities. And we use S3 as well for additional resilience and additional durability so that we can provide backups of these databases. We use RDS snapshotting, and then storage on S3, which is highly durable, which gives us high confidence that in the event that something does actually go wrong, that we can easily recover from it. But we don't stop there. We also use serverless design pattern. So in our serverless design pattern, we've found that we can deliver features and functions very quickly because we don't have to worry about the servers they're running on. We don't have to worry about the auto-scaling. We just deliver the functions, and we use these managed services. That allows us to quickly deliver new things and to focus. Our programmers are programmers. Our software engineers are software engineers. They're not IT people. So they want to focus on what they do best, which is writing code. We allow them to do that, and we have a number of services that are designed entirely serverless. Oftentimes, when we use this pattern, it's when you have things like asynchronous processing, when you have services that can tolerate a little bit of latency now and then, when you have services that are not heavily utilized. And this allows you to achieve a lower total cost of ownership because your infrastructure costs become consumption-based. It's a pay-as-you-go model. So the more that you use, the more it costs. But the more that gets used, the more revenue your platform is generating. And so there's a tie-in between the cost model and the revenue model. And this allows us to maintain very, very low cost. In addition, by using the serverless technologies, we get to borrow the SLA from AWS. And so this allows us a high level of scalability without worrying about all of the underpinnings to make that happen. And you can see, actually, and I think Werner Vogels talked about this a little bit this morning in the evolution of serverless architectures and how more and more people are using serverless architectures these days. And what we see is a gradual shift from physical machine to virtualization to cloud computing, containerization, which was very popular, and now serverless, which is becoming very popular. And this allows us to increase our productivity because, again, our developers are developers, and they want to focus on writing code that delivers functionality. And by leveraging these serverless architectures, we're able to do that and able to operate at speed and innovate quicker. Another design pattern that we adopt within the MindSphere ecosystem is around our data lake. Everybody wants a data lake. Everyone wants to build a data lake. But the problem with a data lake is if you don't really know what you're doing and you don't really have any purpose, you can easily turn your data lake into a data swamp. And then the value proposition is lost. And so what we do is we understand the scenarios in which our platform are going to be used. We're in the industrial space, and we have a great deal of knowledge in the many years of Siemens working in the industrial and manufacturing space. And we use that to apply to our data lake technique. We know that we're going to collect IoT data. We know that we want to enrich the IoT data with other data sets from design, from simulation, in order to close the loop, to improve your designs, to improve your processes, and optimize your manufacturing systems. And by doing this, we can design our data lake in such a way that is optimized for the use cases that it's going to be consumed for. By doing this, we prevent ourselves from just becoming a data swamp. So it seems very interesting, but it's actually very challenging when you wind up delivering this and running this at production scale. And I want to tell you about some of the challenges and some of the lessons that we learned along the way. The first was about unpredictable workloads. If we start with this basic reference architecture about a high throughput streaming ingestion pipeline, we can see that hook up Kinesis, run some Lambda functions, process your data into a hot store in DynamoDB, into S3 so that you can analyze the data later, and maybe provide Elasticsearch on top of it so you have quick access to data. Unfortunately, the real world is never what you expected. And so when you deliver this into the real world, you find that devices may not be always connected. You expect a continuous data feed, and you design your system for a continuous data feed. But what happens in the real world is devices are disconnected, they collect data for a period of time, they suddenly send you bursts of data, and so the workloads are very unpredictable and not what you normally would expect. There are some techniques that you can use to help you address these challenges, such as over-provisioning for the worst case scenario, but doing so actually increases your costs significantly. And so we don't want to over-provision just for the worst case, but we want to react instead to the real-world workloads that we get and provide a scalable architecture that allows us to still keep our costs low and still address the scalability needs that we have within the system. Also, put buffers. If you have an ingestion pipeline, make sure you allow for buffering, because something might bottleneck at some point. And if you have a buffer in place, this allows you to protect yourself and make sure that you never lose data. One of the most important things to MindSphere, beyond security, which is probably the most important, is never losing customer data. So we want to make sure that we protect that ingestion pipeline in case we run into bottlenecks so that we can catch up by putting buffering in place. We also learned that sometimes it's a device that's connected and sending continuous real-time data. Other times, customers want to try out the platform or want to get up and running on the platform, and they have a lot of historical data that they want to upload to get them started with their analytics and unlocking those insights from their historical data. In addition, many times devices can be offline for a number of days, and they want to batch upload these data sets. And so separating real-time and historical workloads will also help you protect your real-time ingestion pipeline and prevent bottlenecks, and allow another path for things like batch processing. We also noticed a lot of different mixed workloads, that different devices operate differently. Some devices collect a large number of attributes and send it once per second. Some devices send a tiny bit of data every millisecond, and we know that they all work a little bit differently, so we can't treat them all the same all the time. So the first change that we introduced was to separate the real-time from the batch processing. This allows us to prevent large file uploads and historical uploads from bottlenecking the ingestion pipeline. Real-time data needs to be processed very quickly so that you can make decisions very quickly in near real time. But if the data is old, if it's historical, if it's 3 days old, maybe it's not necessary for you to make a real-time decision because that was 3 days ago. So why not allow a slower process, more of a batch process, to handle those scenarios and not bottleneck your real-time ingestion pipeline with data that's kind of old. The other change that we made was to understand that all devices are different, and different devices require different throughputs, different bandwidths, and maybe providing one system that tries to handle all of these different scenarios is not optimal. Again, it goes back to over-provisioning. Do we want to over-provision and spend the cost for the worst case scenario, or do we want to provide low cost for devices that have a lower throughput requirement and higher cost, higher performance for things that have high throughput requirements? So by separating these workloads, it allows us to provide the right solution for the right customer at the right cost. And by doing this, we can manage our cost and our scalability. The challenge is when you operate at the scale MindSphere is operating at with thousands of tenants, it's not so easy to just have separate DynamoDB tables, for example, per tenant, because there's always account limits and you have to be aware of the AWS account limits and design around them. So one strategy is to actually bucket things into low cost, low throughput, maybe medium throughput for medium cost, and for those customers who really need high throughput, provision and give them that high throughput. But this allows you to do tiered pricing that allows you to focus each workload with the right infrastructure necessary for that workload. So some of the key learnings: you need to understand when you're designing on AWS, there are service limits. There are ways that AWS works to protect you from spending too much money, to protect you from not doing things appropriately, and there's service limits. And you need to know what these are and design with them in mind. So if you have upper boundaries, you need to know what they are, and you need to put those upper boundaries within your system, and you need to design appropriately to handle the service limits that AWS has. You also need to know that scaling takes time, and we heard some great announcements this week about how that's actually speeding up with some of the new features coming. But scaling takes time, so make sure that you're monitoring your workloads, you're monitoring your systems, and that you scale appropriately. Plan for additional time. If you have EC2 instances running on ECS, you want to make sure that if you have a peak in workload, you can scale out to achieve the performance for that increased workload for peaks and valleys. Otherwise, you might run into problems. So plan for the time that it's going to take you to scale out your infrastructure. Again, the real world's not what you expect, so watch it, monitor it, continuously monitor it, learn from how your systems are working in the real world, and continue to adapt. That's the most important thing, because when you get out there and put your software in the real world, it may not behave exactly how you expect. When you're delivering such a platform with APIs, developers are using your APIs, they may not always use your APIs the way you expect them to. So you need to constantly monitor usage patterns. You need to understand where your workloads is coming from and where your loads are, and make sure you continuously adapt your systems to address those challenges. One thing is serverless does make this a lot easier, but there are still limits within serverless, and you still need to know what they are. For example, if you're running Athena workloads, it's a wonderful technology, it performs well, it's very low cost, especially if you don't have constant load on it, but the number of concurrent queries that you can run may have an impact. So you need to understand the limits of the systems that you're working with and design around them. One of the things that we learned is about cost optimization. You can do a lot of things to plan for your future workloads, but you want to make sure you're spending the right amount of money and you're not overspending. So part of this is understanding how to predict the costs of your architecture as it's running on AWS. AWS has cost calculators that make this much easier. This is an example from DynamoDB. And it's important for you to understand that there are many factors that go into the cost model. And by understanding these, you can design your systems to be cost effective. For example, in DynamoDB, there's storage cost and hot storage. That is our hot storage layer in DynamoDB. The amount of data and the retention period will impact the cost. But that's not the only cost factor. There's write capacity units and read capacity units. And you need to understand how these factors influence it. Because again, delivering APIs, developers are going to build applications. And if they're constantly polling your API to read data, you need to know how that cost is going to translate into your cost on AWS and plan for it. You can also use provisioned versus on-demand capacity. So if you have run in production for some time, this is, again, why it's important to monitor your workloads and to monitor your usage. Once you have a good understanding of your constant or average workload, you can purchase provisioned capacity. And the provisioned capacity allows you to have a lower cost for those fixed known workloads and allow yourself to have on-demand resources for more of your burst capacity. This allows you to balance both the scalability and performance against the cost. So you're only really paying for what you need, and you can get a lot of benefit once you understand your workloads by using provision capacity. Some of the general best practices that we've learned about cost optimization are, number one, most important thing, automate everything. If you automate everything, everything else you do becomes easier. Everything else you do becomes reproducible. So our first rule is automate everything. The second rule is turn it off when you're not using it. So probably most of you own a car. You probably don't leave it running in your driveway all the time, because that would be a waste of gasoline. So we do the same with our EC2 instances. Don't leave them running when they're not in use. If you're in a development environment especially, 30% of your yearly cost are weekends. And so shut systems down when you're not using them, and that really helps you to manage your costs. In development doesn't have the load or the capacity or the HA requirements that you have in production. So plan for your development environments to be low cost. Don't spend a lot of money there that you don't have to spend there. For example, you can use reduced EC2 instances. You can use T3 instances, which cost a fraction of the cost than what you might need in production to develop and test your systems. Right-size your instances, manage your caches. One thing we learned about our Elastic Cache was large objects in Elastic Cache cost a lot, so make sure that you are caching what's necessary to achieve the performance, but not overutilizing it. SQS, we use quite a bit to decouple services, and SQS is a pull system versus SNS, which is a push system. So when you have data in SQS, you fetch data from SQS. And if you're constantly polling SQS, your cost could go up quite a bit. And so understanding different techniques like long polling on SQS can help you reduce costs. Things like using SNS, which is a push notification. When something's there, go and do something about it, rather than constantly saying SQS, do you have data for me to process? No? Okay, do you have data for me to process? So you just kind of react when things are there rather than constantly pulling the system. Plan for your infrastructure based on real usage patterns, and make sure that you're using the tools AWS has to help you understand your costs and optimize your costs. The billing console is invaluable for this. You really can see where you're spending your money, what services are costing you money, and the Trusted Advisor also gives you really good hints if you want to optimize. So it'll tell you if you have EC2 instances that are over-provisioned and underutilized. If they're sitting around using a small percentage of CPU, you probably can right-size them or maybe even move that to serverless and run that workload on Lambda. One excellent example of this is when we shifted this operational data store from a server-based ECS plus RDS into a completely serverless architecture. We were able to achieve a 90% cost reduction by making this change. What we found was this operational data is used to provide usage reports, both for us as well as the application developers who develop applications on top of the MindSphere platform. But this does not have to be real-time reporting. So setting up an infrastructure that is high capacity, real-time, using Kinesis plus DynamoDB was very expensive. And what we learned was you don't really need that really fast, low latency, high throughput infrastructure to generate these types of reports that people look at maybe once a week or a couple of times a month. So by switching this to a serverless architecture, we're using the right tools for the right job. And we use Kinesis Firehose, dump the data into S3, which gives us durable storage. Then we use Athena to pre-process the data into the pre-aggregated formats that will serve up for reporting. And then we can even use Athena from our user interface to query the data and provide the actual charts that we need to understand our usage patterns and that our customers use to understand the usage patterns when they're using the system. So there's a lot of opportunity for cost optimization in these types of scenarios by leveraging serverless architectures. It's important to understand that your architecture needs to be evolvable. And what we've learned the most is that things will change, your usage patterns will change. As more customers come to your system, your loads will change. As new requirements come to your system, your requirements on your systems will change. And it's important to understand that this has to be something that you can evolve over time, and you have to be able to adapt your system as the world around you changes. So it's not just about building and delivering the platform, but it's also about how do you deliver and operate the platform. So MindSphere is designed as a microservices architecture, and we slice and dice our functionality into various smaller building blocks and smaller microservices. This allows us to very quickly and easily deliver new features and functionality, and we can release, deploy, and scale each of these services independently based on their needs. And therefore, we can also provide each service the right compute and the right infrastructure for its needs. In addition to that, when we get ready to release new services into production, we want to make sure, although we have design patterns, we want to do a second check to make sure all of our services are going to live up to their expectations, that all of our services will meet the SLAs and the security requirements we have within our platform. So we came up with operational readiness checklists. One interesting story is in 2017, we were getting ready to go live, and we were here at reInvent, and myself and our head of operations were sitting here determining how do we make sure that when we go live, everything is going to operate, that we're not going to have any downtime, everything's going to be secure. How do we just double check that? So we came up with this operational readiness or production readiness checklist. We're sitting on the floor with our laptops, typing it up, and we took it back to the teams, and we went through each team and did a review to see how well that team had implemented our best practices, how well that team was adhering to the well-architected framework. And by doing this, we were able to ensure every team was able to deliver their service with the proper security, with automated backup and recovery, with real-time monitoring and health checks. And this really helped us when we went live to ensure that there were no problems and it was a smooth delivery, and we had a smooth operational ramp up as customers started using our systems. It allowed us to ensure we had complete visibility into what was happening with our services, and when there was a problem, we were automatically notified of it so that we can address it even before a customer would see the problem. And the part of the way we deliver these services, again, is through automated processes. By automating our processes, we're able to scale these practices to our global team. We have developers all over the world. We have over 60 development teams developing services and new functionalities and features. And we want to make sure that they're all delivered with a common set of tooling so that we have standardization across the platform. So requirements come in, they go into our task tracking system, developers write code, it gets deployed, it gets committed to our source repository. Automated builds take that code, run the automation, they compile, they do static code analysis, they do unit tests, and then everything is deployed. And all of these are completely automated systems. And this allows us to achieve the speed of delivery for continuous delivery. In addition to delivering the software, we want to monitor the software and make sure that we always know what's happening in our production environment. So again, the key to doing this at scale, at MindSphere scale, is automation. We have CloudWatch that monitors what's happening within our EC2 instances. We have health checks that check the health of our services and make sure that our services are up and running. We have systems that gives us charts so we can measure the uptime. But we don't just measure uptime and performance, we also continuously measure security aspects within the platform. We have a combination of guard duty as well as custom Lambda functions that check for our security best practices. And these are run in every stage of our deployment. So we can catch mistakes before they ever get to production by running the same tools in our development environments. It's a completely automated system. If anything ever does go wrong, the system attempts to self-heal itself. If the system cannot self-heal itself, we have an automated pager duty that triggers our DevOps teams. And we are truly DevOps. You build it, you run it. So our teams that deliver our microservices actually own the operations of their microservices. And so if the event that something does go wrong, the team gets a page, they know exactly what's happening, and they can immediately respond and immediately resolve an issue, usually before a customer even notices any issue occurring. We do the same with security. So we have continuous security monitoring within the platform. If anything with respect to security configuration changes, if we detect any issue, we're immediately aware of it. And we automate the response. We automate also a corrective action and a preventative action for the future by taking anything that we find, whether it's a performance problem, whether there was an outage, whether there was a security incident, it immediately generates a new task in our JIRA system so that we can prevent it from ever occurring again. We have only 0-day issues, and our ops team refers to it because they only want to see an issue once. They never want to see the same issue occur more than once. And this process helps us ensure that, so we can deliver a high quality of service. Some of the key takeaways from today that I'd like to leave you with: it's important to understand your architecture is aligned with your business strategy. Talked earlier about building an ecosystem and focusing on differentiators. By doing this, you're aligning your architectural strategy with your business strategy. And you're focusing on the aspects of your technology and the aspects of your architecture that actually deliver value to your customers. You also have to really focus and invest in security, reliability, and scalability. Well-architected framework, some of the pillars: security, reliability, performance efficiency, operational excellence, and cost optimization. And the key, most important, is security. You want to protect your customers' data, and you want to protect your customers. And so make sure that you are thinking about these aspects, not just at the end, but every step of the way through your design and your development processes. Plan for change, because things will change, and you have to be able to adapt when things change. The technology landscape is changing every day. It's very hard to keep pace with it. How many new services got announced this week? A lot. So you have to plan for change. You have to plan that your usage patterns will change. Your requirements are going to change. The technologies available that help you deliver your solutions will constantly change and evolve. And in order for you to keep pace with a changing world, you really have to be willing to monitor, adapt, and change as the world around you changes. And by designing your systems and your architecture with this in mind, you can evolve your architecture as the world changes. Very important to keep track of what's actually happening in your system at all times. Monitor, measure everything, analyze what's happening, understand usage patterns, understand when you have peaks and spikes in your workload. What could be the result of that? Are there patterns in that you can learn from so that you can proactively scale your system? If every Friday at 9 a.m. you see a spike, maybe you need a time-based auto-scale policy that addresses that. So constantly monitor your system, constantly analyze what's happening with real-world usage, and plan for continuous improvement. Most importantly, practice and experiment. By experimentation, try new things. Don't be afraid to try something new. This is one of the key principles that we try and teach our development teams. There's a lot of things out there. There's a lot of new technologies out there. There's a lot of new ways of doing things. Be free. Try things. Experiment with things. Try those new technologies. See how they benefit your system. Do it quickly, learn from it, adapt, and apply it. And practice. We run game days and fire drills. You have fire drills in a building. It teaches you how to get out of the building when there's a fire. Because when there is a fire, you don't want to have to think about it. You just want to get out of the building. You want to know exactly the path, and you don't want to worry. Because when there's a fire, people might panic. If the production system goes down in the middle of the night, you might be tired, and you might not be thinking as you would if your mind was fresh. So practice so that when something goes wrong, Werner Vogel said it today, something always goes wrong. Something will always fail. So design for resilience and practice what you need to do when something does go wrong. One of the techniques that you can use also, chaos engineering. Actually simulate scenarios in your platform. Simulate a node failure, simulate a network outage, simulate a slowdown in your network performance, simulate a RDS failure on your primary node, and measure how your systems recover from these scenarios. Because the more you learn from these experiments, the more you learn from this practice, the more you learn from your chaos engineering, the more you can design more resilient systems so that you can achieve a high level of SLA and keep your customers happy. So thanks a lot. Really appreciate you coming today. If you have any questions, I'll be here.